This conference will now be recorded.
Well, since I hope everyone is here and we have a lot to cover, we really should begin our today's conference. I really appreciate you all for attending today's conference. A very good morning, afternoon, or evening, one and all to present here virtually with me today. Let me introduce myself. My name is Rachel McLean, Conference Secretary at Coalesce Research Group LLC, and I will be available for any of your queries or questions throughout the conference to help you out technical and organize the conference successfully. Before we start with the sessions today, I guess some of you will be new to the GoToMeetings app. Let me just explain you the important tools required for the presentation. On the GoToMeetings app or web page, you can find four icons at the bottom. One is for mic, camera, screen, and end buttons. Mic button, click on the mic button to mute or unmute yourself. I request you all to stay muted while our speakers are presenting the research work so that it does not cause any disturbance to them. Camera button, you can use this button to share or unshare the webcam. If you have the option to share the webcam, you can do it, and that's completely your choice. Screen button, you can use this button to share your screen. This is the main part during your presentation after I call your name. From my side, I will be making you as a presenter, and only I'll give the permission to share the screen, then only you will be able to share your screen. So once I make you the presenter, you can click on the screen button and you will find a pop-up window to share your screen. End button, this is your fourth icon where you can use this to leave the session. On the on the top center, you can use the options to change your display settings. At the top right corner, you have three icons: people, chat, and settings. In that chat option, you can chat with me or any other participants. For the settings, you can use this button to check for the settings of your speakers and microphone. As I mentioned, kindly remain muted during the presentation so that the presenters do not get disturbed. And for any questions, you can ask the questions or you can send your questions in the message box too. Well, that's not to take much of your time. Finally, I would like to request you all to please give us a brief introduction about yourself before starting with the session so that we can know about you virtually. And now let's move into our today's sessions. Our first presenter is by Dr. Nalini Kanta Soho from SRM Institute of Science and Technology, India. Doctor, are you ready with your presentation?
Uh,
Dr. Nalini
madam,
Kanta.
yeah,
Yes.
yeah, madam. Can you please
Okay. Now,
start with the second presenter of mine? Then I'll give in the second because I am in mid of the meeting actually. If you don't,
okay.
yeah, I'll go with the second
Okay.
presenter. If you can uh, continue
Okay.
with the second one
Okay.
who is there or any other. If you, it's my
Okay. Okay.
yeah.
Yes. Okay.
So
Thank you.
I'll be joining after half an hour because I'm in the middle of the meeting.
Okay.
Yeah.
Thank you. Our next presenter is by Dr. Nimed Shunati from Udania University, Indonesia. Doctor, are you ready with your presentation?
Yes, thank you.
Okay. Thank you. Now I'm going to
Recording.
make you as a presenter now.
Yes, I prepare.
Okay. Please do share your screen now.
Oh no. Oh, I don't share. Yeah.
Please click on the PowerPoint presentation. I think you have already opened it.
Hmm?
Yes. Please click on the PPT.
It's okay.
Yes. Yes. Can you make it as a
Yeah.
full screen by clicking slideshow button?
Yes. Oh, I don't
In the
see
bottom towards in the bottom
button.
towards fourth icon.
Oh, I don't see. But close. our name. Waiting, yeah, as waiting. Content, gedein.
In the bottom of the PPT, you will find note, comments, and beside that you will be having slideshow option also. You need to click on that fourth icon after the comments. Yes. Thank you. Please continue with your talk now.
Tertutup nih. Yes, it's okay. Thank you for the time. I'd like to present our paper. The title is Analysis of Virgin Coconut Oil Lemongrass Compared to Standard Quercetin by Gas Chromatography Mass Spectrometry. Why go to next slide? Hello?
Yes, doctor. Hello.
Yes? I
We
go
can
to
hear
next
you.
slide. Yes? What I click, yeah?
Oh, you need to click the arrow buttons to paste down. Please click on the paste down button.
Button? No.
Or else, yes. Please click
Yes.
on that.
Yes.
Okay.
That's the outline of the research, introduction, methodology, result and discussion, and conclusion. Then the introduction, virgin coconut oil lemongrass extract are expected to increase its antioxidant level based on MUIS 2009. Methanol extract into virgin coconut oil is able to increase antioxidant activity because it contains mineral components such as phenolic compound. Lemongrass extract is able to inhibit lipid peroxidation to inhibit free radical in biomembrane. The content of other compounds such as citronella, geraniol, and citronellol in citronella oil is known as an antibacterial compound based on Luang 2007. This is also supported by Kumaraningsih 2009 then that natural antioxidant in plant are general phenolic compounds, namely flavonoid compound and tocopherol, as well as other organic compounds. One of the antioxidant is quercetin in our research. Next, important to analyze the virgin coconut oil lemongrass by comparing quercetin standard as one of the antioxidant using gas chromatography mass spectrometry. The aim of this research analyze virgin coconut oil and virgin coconut oil lemongrass to compare quercetin standard by gas chromatography mass spectrometry. The methodology tool analytic balance, filter, coconut filter, cotton swab, beaker, Erlenmeyer flash, measuring cup, panel, system and condition of GCMS KV 2010. Ingredient: all coconut oil, pressed lemongrass, water, ethanol, pure and standard quercetin, lemongrass powder, mixed to stock and are cut into small pieces and dried, then blended and then filtered. Virgin coconut oil and lemongrass powder or coconut meat and weight about 1,000 gram, then 1,500 milliliter of water was added and squeezed to produce coconut milk and left at a room temperature for about 4 hours. Next, spirited the top, we call cream of coconut milk. Coconut cream was incubated for 24 hours to obtain 3 layers, and the top layer was virgin coconut oil. Furthermore, lemongrass powder and virgin coconut oil were mixed with concentration 5, 10, and 15% respectively. And then the result and discussion we can show in the figure 1. Compound contained in quercetin are standardized by GCMS under selected condition in the N system. We can show the benzene decarboxylate acid more concentration. We can and other compound more, yeah. We can show in the table 1, the retention time quercetin standard. We meet some compound. One is 1 and 2 benzene decarboxylate acid, more concentration, and a little ethyl laurate, palmitate, and derivative ethyl laurate, and in small percentage, yeah, percentage. And then we can show the figure 2, compound contain quercetin and virgin coconut oil with and without lemongrass, various concentration by GCMS under selected condition and system. We can show in the figure 2, benzene decarboxylate acid, we meet all sample and quercetin standard similar. We meet more percentage, and other compound a little, yeah, a little percentage. We can show here this is a quercetin standard, and then virgin coconut oil similar with quercetin, and then virgin coconut oil with lemongrass 5%. This is 10% lemongrass, and then at the end lemongrass 15% and PCO. This is a good separation and resolution by GC and identified by MS. Yeah. And then the percentage of compound is quercetin standard and virgin coconut oil without and with various lemongrass. We can show quercetin is maximum benzene decarboxylate 69%, and then similar with control 93%, and then increase with lemongrass 10% until 76%, and then increase again with lemongrass 15%. Lemongrass, and we meet benzene decarboxylate acid 76.87%. And other compound we still meet other component. maybe not good. Maybe I want to develop in the next research and repair the result. Yes, we can show here mass spectrometry ethyl laurate. Ethyl laurate is a fragment iron ethylate. And then fragmentation pattern of second compound was ethyl palmitate. Retention time 15.9 minutes, and analysis by MS also mass per iron ethylate. Yeah. And mass spec 318 according the Willy literature. So 96% conformity and formula, and we can here and mole weight to 184. This is mass spectrometry 1 and 2 benzene dicarboxylate acid. Mass and ion 149. This is maybe the structure of benzene dicarboxylate acid. We can show here and 97%. Yeah. This is benzene dicarboxylate acid. And then fatty acid that contain one or more double bond are called unsaturated fatty acid, obtained from the hydrolysis of lipid, usually contain a mixture of saturated and unsaturated fatty acid. Vegetable oil mostly contain palmitic acid, stearic acid, oleic acid, linoleic acid, based on Armachier 2009. The ester and fatty acid were detected about 12% as a volatile compound based on Jock et al. 2004. Fatty acid compound in phytochemical screening in Eruca sativa leaf extract were taken from the market and analyzed by ECMS as allyl ester compound based on Tuka et al. 2016. Analysis quercetin in ginkgo biloba leaf extract by GCMS showed precise and accuracy result based on Abrasa et al. 2017. And the conclusion, virgin coconut oil, lemongrass analyzed the ethyl ester known as fatty acid ethyl ester, ethyl laurate, and ethyl palmitate, and benzene dicarboxylate acid at retention time and here and 11, and 15 and 22 minutes respectively. We can so here the resolution is good resolution by GC, and the identification with MS we meet mass per ion, ethylate, ethyl ester, and 149 as benzene dicarboxylate acid. Yeah, in conclusion, and the final is knowledge. The other would like to thank Director Research and Community Research, Directorate General Strain Research and Development, Ministry Research, Technology, Higher Education, Research and Community Service Institute, and Rector Udayana University, in according with the research contact number here and date to June 2021. And this is a reference. Maybe in future I would like to get reference other reference to refer my research material. And that's it all. And thank you. And I want to back to Raquel. Yeah, thank you.
Thank you, Dr. Naimad. Is anyone having any questions?
Can I stop sharing?
Yes, you can.
Yes.
Thank you. I think there are no questions. Let's move to our next presentation by Dr. Nalinikanta Sahu from SRM Institute of Science and Technology, India. Doctor, are you ready with your presentation?
Yes, madam. I'm ready.
Okay, please click on. Okay, now I'm going to make you as a presenter now. Please share your screen.
Is it audible?
Yes, we can hear your voice. Yes,
Sure.
I made
I'm
you as a
sharing.
presenter now. Please share your screen.
Okay, I have shared. I think, is it visible?
Yes, yes, it's visible. Can you make it as, please click on the slideshow button.
Sure, sure. Just a minute.
Okay. Mhm.
Yeah. Now is it okay? Fine.
Yes, it's perfect.
Yeah. Thank you.
Please continue with your talk. Thank you.
Thank you for giving this opportunity, and I hope I'm visible also, and I have switched on my camera. So today I'm going to give a talk on high resolution mass spectroscopy for targeted environment exposomes. So what does it mean actually? Exposomics. Mainly, as you know, there are different kinds of things are there which may cause some of the diseases. Am I right? So we need to detect it. We need to identify their presence and you can say environments, those contaminants, those who pollutants, which may cause some disease, which may cause some allergy, which may cause some means unwanted reactions, or you may say some adverse reactions, or those are called exposures mix, and how to find their presence in the environment. So that is my talk today, and you can see here. The topic that is almost related to your LCMS. This is an analytical technique, how we are using this analytical technique for the identification of this particular exposomics. Okay, so one question is coming in our mind, that is, what are the next emerging contaminants and how we can find them in the environment? So this is a big question nowadays. Okay, so many contaminants are there in the environment, and how to know their presence, whether means how much quantity is present, and how to know their presence also. For that, what are the different sophisticated techniques we are using? Okay, and how we are using the procedure methodology, that I'm going to show today. This is the talk especially containing. So as you can see, what are the next emerging contaminants? How can we find them in the environment? How we are going to identify those? You can see here different departments, means different studies are there, like Department of Genetics and Biochemistry. Those people are going to identify some of the genetic level work and different your metabolomic and whenever so particularly this is a related to identification quantification work, how to quantify the presence of those exposomics. And if you see here the technique, that is LCHRMS, an emerging technique for environmental exposomics. LCMS strategies for characterization of organic contaminants. As you know, different types of, mainly the solvents we are using, organic solvents mostly, in every kind of synthesis, every kind of your research work. We are using different types of organic solvents, organic compounds. So many of the you can say contaminants are arising from those. If any impurities are there in those organic compounds, then they may act as your organic contaminants. So now we are going to study here LCMS strategies for characterization of organic contaminants. How to find or how to identify the presence of or how to characterize the organic contaminants. What organic contaminants are present, right? So basically screening technique question is coming. What screening technique we are going to identify? We are going to use, right? So there are three types of techniques we are following for the presence of exposomics, like targeted, one is suspect, and one is your non-target. So targeted means suppose compounds contaminants present XYZ, we are going to identify their presence in the sample. So those are coming your target. We know that this X or Y or Z, these contaminants are present, and we are going to identify. No, what are there? Only to identify their presence, right? So what are present and with what quantity they are present. Okay. In the next, as you can see here, this next target is your suspect, right? So suspect method. In the suspect method, what we are doing, which compounds of a defined list are present in this sample. In the sample, what are the compounds present, defined list? Means you need to characterize it because we don't know what are present, and we need to identify their presence. We are suspecting what may be present, right? Another one is your non-target. Non-target means which compounds are present in this sample, because apart from these impurities, we don't know what are the other exposomics presents. And if you are able to identify those exposomics other than the known one, is known as your non-target, because we are not targeting anything, right? We don't know anything what is present. Okay, so what are not present or what are present probably, that we are going to find out here in these kind of analysis. So in these kind of estimations, like as I said you, three types: targeted, suspect, and one more is your non-target. Okay. And you can see here one of the statement, that is there are known knowns. There are things we know. I think you are able to understand, means what I want to say. Many things we know that is present in that. There are the things we know which are present, and we also know there are known unknowns, and we know that some unknowns are which we don't know. So that is why we are going to characterize, right? So that is to say, we know there are some things we do know, we do not know, but there are also unknown unknowns. The ones we don't know, we don't know. So it's a very complementary thing to this particular study. So you can see here, I have made some of the things like some hypothesis I have done here. When we are doing some LCMS characterization, LCMS strategies for characterization of organic contaminants. Sorry,
ওটা বাইরে দিলে যে দিনটা গরম না, একটু মনে হয় সমস্যা হতে পারে কিছু কিছু বস্তা
from the background. Sorry,
তাহলে দেখো তো ওটা, আচ্ছা যদি বস্তা যদি রিপ্লেস করা লাগে করে নাও।
I request the host, can you please mute somebody? I think there is a noise from the background. Yes. So LCMS, HRM is an emerging technique for environmental exposomics, and in this, as you can see, screening technique. In this screening technique, as you can see, what are the screening technique we are following and for which compounds, right? So there are three, as I said you: targeted, suspect, and non-target. So in the target, what are XYZ, what are present in that? We know XYZ are present, and we need to, right, suspect which compounds of a defined list are present in the sample. From the defined list, what are present in that sample? That we are going to suspect here. And in the non-target, which compounds are present in the sample? Which compounds are present in the sample, right? And in the compound types, as you can see here, known knowns, targeted, known knowns, because we know these are present and we are going to identify. Suspect, known unknowns, means we know some unknowns are present and we are going to find out. Am I right? And non-targeted, that is known unknowns and unknown unknowns. Known unknowns means we know some unknowns are present, and sometimes we don't know what unknowns are also present. So that is the main objective of your non-target. So this is basically coming under your exposomics. How to identify the exposomics, how to estimate the exposomics by using high resolution mass spectroscopy, LC-HRMS, that is liquid chromatography, high resolution mass spectroscopy. Okay, by using this. As you can see, why do we use HRMS? One of the major questions coming to our mind, many of the analysts, when they're doing the research, so many of the things it is coming to their mind. That is, why do we use HRMS first for non-targeted analysis of pollutants? Why? Why we are using high resolution mass spectroscopy for non-targeted, not other things? The reason is that it's very sensitive, right? High resolution. With resolution R value 500, this is 5,000, it is 50,000. So how much, with what resolution it is going to separate those peaks and to identify? You just imagine how much sensitive it is. Because of its high sensitivity, we are using this HRMS technique for the detection of the pollutants by using non-targeted technique, right? Mass error, as you can see here, very little mass errors are there. Okay, as you can see, 5 ppm we are using, 50 ppm we are using, 500 ppm we are using. The molecular mass you can see here 0.0012 Dalton, here 0.01117, 0.1175. So this much of your atomic mass we are going to identify, the fragment mass. So very sensitive, this one, very sensitive when you are taking a little amount of your solution, concentration of the solution, right? So that is why we are using this particular HRMS technique for the identification of presence of some exposomics. You can see here some semi-volatile organic contaminants in the environment. So many contaminants are available in the environment. So many organic contaminants are available. Some are volatile, some are semi-volatile, some are non-volatile. If it is semi-volatile, it's very hard to find their presence, right? It is very difficult to find their presence. So as you can see here, research on SBOCs has focused on occurrence and effects in the ambient environment, and there have been few comprehensive studies on human exposure indoors. Okay, and as you can see here, they are applied to consumer products to enhance performance or durability, right? Sometimes what happened, some kind of exposomics people are using, the vendors are using in the consumer products. Why they are using? To enhance their performance. Sometimes they are using for its increase in performance or for the durability, right? Like example I'm giving you, phthalates in personal care products. Some of the beauty products are there. In that, one of the exposomic is there, that is your phthalates. So these phthalates we are using in this personal care products to increase its durability. Some of the flame retardants in furniture and electronics. Some electronic products are available, as you can see here, and some of the your home appliances are there. So in that we are using this flame retardant inflammations, right? So that is the reason why we are using in that. Some kind of things like your bisphenol A in water bottles. Some of the water bottles in that, one of the composite, that is your bisphenol A, we are using. Surfactants in cleaning agents, some of the cleaning agents we are using surfactants, and some of the antioxidants used in food packaging, but they are acting as exposomics. Okay, so these are for usefulness, means sometimes we are using these things to increase the durability, means it will preserve for more longer time, as well as it may protect from other means harmful hazards, right? So why study SBOCs indoors? Why we are studying actually? Some SBOCs are potential endocrine disruptors. Some of the things, they are endocrine disruptors. They are disrupting the endocrine system, like bisphenol A. It's a is a xenoestrogen, right? Bisphenol A is a xenoestrogen. Flame retardants have been shown to flame retardant we are using sometimes in the household things or electronic products, but they are causing thyroid hormone. They are affecting the receptor of your thyroid hormone, right? So 87% of our time is spent in indoors. So we are spending maximum time in indoor zone, right? Wherever, suppose you are working in one any office, or you are going to home, so you are interacting with a different kind of your home appliances or indoor room, right? So that is the reason why we are going to be exposed to different contaminants every time exposure, and there is a chance also these may affect your system, right? So exposure through inhalation, ingestion, dermal absorptions. Dermal absorption means sometimes they may be absorbed to your skin, and when we are inhaling, those exposure mix also may be inspired through breathing. Ingestion, sometimes it may be gone through food, right? So objective, what is it? Access human exposure. Slow baat karna. So access human exposure to SBOCs from the indoor environment through non-targeted analysis of paired. This is the main objective why we are going to study this presence of your exposomics. The presence of exposomics. You can see here allergic analytical strategy for dust and hand wipe. Okay, sometimes we are using hand wipes. Your dust also. How to identify their presence means analytical strategies. You can see here most indoor exposure analysis has applied gas chromatography, mass spectroscopy, focus on non-polar organic contaminants. Generally these GCMS we are using for non-polar organic contaminants, and liquid chromatography when it is coupled with your HRMS, your LC HRMS, we are using for characterizing semi-polar organic contaminants. Non-targeted data we are using for de novo identifications, and sometimes we are using the approach that complements both targeted quantitative analysis by LCMS and GCMS. So generally these two techniques are we are using to know the presence of the exposomics. For we are using different types of analytical strategies. So coming to the procedure, how we are going to use this one. If it is, you can see here 10 people are there. Dust and hand wipes. So dust and wipe blanks. So we are taking sample, we are preparing from 10 people. We are taking the sample. They are inhaling with any, you can say, uh, their excludes whatever they are eliminating to the environment. So their sample we are taking of maybe any saliva sample or anything sway in terms of sway food exude, you can say. So from 10 people we are taking, and then dust and hand wipes were spiking, and some sample we are preparing. Means this sample whatever we are taking, it is spiked with, means they are inhaling, they are inject in means intaking through food or through mouth or anything. Then we are taking that sample and we are analyzing. Some sample we are taking with dust and hand wipes, and some sample we are taking without those. Means those who are not exposed to the exposomics. From them also we are taking the sample. Then after taking the sample, we are going for the extraction, because in that also other enzymatic proteins, everything will be present.
Namaste.
So we are separating it by some of the method like sonic acid, right? With some of the organic solvent like hexane, dichloromethane with a ratio 1:1. We're maintaining and we're preparing the sample. Then those sample we're exchanging to 10% acetonitrile in water by using speed back, sonic acid and centrifugation, right? Then we are injecting into, as you can see here, your liquid chromatography LC, means HPLC, which is reverse phased, means equipped with reverse phase column C18. Mobile phase generally we are using 10% acetonitrile to 90%, 99% in 60 minutes runtime. And we can see here the mass spectrometry either the ionization technique ESI resolution 60,000 with this mass by charge ratio, that is 400 top 4 data, and with the CID, all these optimization parameter we are normalization factor 35, we are just doing, and we are running through the mass spectroscopy, right? And we are getting some peaks, presence of exposomes. So this is a generalized procedure how we need to go for your presence of exposomics. And coming to comprehensive 2D liquid chromatography, in that size exclusion or reverse phase separation, it may run up to 90 minutes, 2-minute segments, every 2-minute segments. The detector we are using analyzer Orbitrap Veloz, same ESI resolution this much, and we are going to find their presence. The peak you may get like this, right? So this is the thing when we are going for using MS, and if you are using 2D liquid chromatography, the peak may be this, right? So two-dimensional UHPLC. UHPLC means ultra high performance liquid chromatography. So this is the overall procedure. As you can see how it is happening. Sample we are taking. First separation it is achieved through the reverse phase column, through valve, means it is going. Second separation, because it is a MS technique, so second separation will be happened, and it will maximum for 2 minutes. 2 short columns we are using generally. It's analyzing, then we are analyzing. This is a 3D plot. 3D plot showing different exposomics, what are present in that. And if you see, for effective separation mechanism must be orthogonal. Size and hydrophobicity, right? So this is about your, as you have shown you 2D UHPLC, right? Coming to 2D UHPLC HRMS configurations. What are the analyzer we are using? UV detector, aerosol detector, orbiter, and fast separation when you are separating it, helic, right? Size exclusion chromatography, SCC, right? So these are when we are using this particular technique, either helic or either SCs. Then we are getting the sample and we are injecting here, then we are simultaneously, right? So when we are analyzing, we are getting some different kinds of peaks. So this is a mass spectrometer, typical you can say workstation for this 2D UHPLC HRMS configurations, right? Then we are processing the data here, discovering the data for peak consolidation and filtering, compound discoverer 2 peak detection, and we are here identifying different types of peaks, right? Now, so this is the technique, this is the analysis technique we are using, how we are going to identify the presence of exposomes. As I have shown you in previous slide, like two-dimensional UHPLC techniques, right? So in that technique, we are getting the peak like this. Okay, presence of, you can just see the spotting. Depending upon the spotting, we are able to know the presence of their exposomes and how well they are separated from each other. So identify with standard, as you some of the alcohol which are acting as exposomes, like C12 alcohol, as you can see here. Ethoxylate, this is one of the exposome. Nonyl phenol, NPEO, that is called nonyl phenol ethoxylate, octyl phenol. So these are some kind of exposomes, as you can see, right? So these are various representation of those in terms of some of the graphs I have shown here. With respect to this one, you can say ethoxylate number, relative peak area. Depending upon that, the graph is plotted. The highest, the peak area whose area is more, or is top one, you can say that exposomic is more in quantity. This is the way how we are going to identify the presence of those your exposomes. As you can see, the gray color, that is dust, and the white yellow color, slight faded yellow color, that is wipes. So in this way they are going to be separated and we are able to know their presence. And how to find their, means how much is present and how much is not present, means how much is present, how to know. From the blank itself, we are doing the minus, we are doing the deduction. By deducting the amount of the peak area, we are able to know how much of the exposomic is present. This is the way how we are comparing with the standard. Workflow strategies for identifying the dust and hand wipes from LC-HRMS. Exact mass identified or not. That is what we are going to do. This is the best picks, as you can see here. Full scan, when we are doing the full scan, we are getting different types of peak. And these are few, you can see some of the exposomes I have shown. And from that, we are generating the formula also, molecular formula, depending upon the fragment, what fragment is formed, depending upon the ratio, fragment ratio, we are able to know what is the parent contaminant, what is the parent organic contaminant. As you can see here, we are correlating some of the software, you can see here, Sirius, that software name is Sirius, SIRIUS. From that, we are able to manage the parent contaminant from the fragment, right? So this is a software, paid software. By using this, we are able to identify. As you can see here, ID 151, and if you see what is 151, actually when they're putting into Cyrus software, they're getting the compound O5S. So depending upon that, they are able to identify the exact molecular formula of the parent contaminant from which that particular contaminant is formed. Coming to ultra high resolution, allows molecular formula by isotope fine structure inspection. Sometimes isotope inspections also means sometimes isotopes are also present. So those isotopes also can be identified. As you can see here, 3 isotopes are there, nearly 531.3610, 531.4490, 531.4061. So these are well mixed and to give this one. So particularly these 3 peaks give rise to togetherly this one, right? So in this way, we are going to know the presence of the particular compound, particular contaminant, or particular exposomic. You can see here different compounds are there, different exposomics are there, like propanoic acid is there, valeric acid is there, propanolol is there, right? Ester is there, declidine is there. So many exposomics are available after characterization. So this is the way how we are going to find out their presence. And some of the example I have given is leased from propylene tubes in mass selective analysis. When we are doing the mass analysis, we are taking some sample in the tube holders, sample tube holders, or sample tubes. We are taking those tubes are made up of some kind of materials. From that materials, plastic materials, they may contain propylene tubes, propylene. So from those propylene tubes, leaching may happen, chemical leaching may happen. Something may be released, some chemicals may be released. And if some chemicals will be released, and they may act as contaminant, and you can say these may act as your exposomics. So these exposomics, when it will pass through the analyzer, then it will interfere in the study. To know that, some studies have been carried out. I have shown here this particular article, authored by Yuan King, Zia, Sefali Patel, Ray Bakhtiar, Ronald B. Franklin, and George A. Doss. These are the famous names. They have carried out this particular work. They have shown their figure. Here the figure. What are the different? How we are going to interrelate or correlate the presence of this particular you can say contaminants or exposomes, right? And if we combine these two, mass bank as well as met fusion for compound ID and HRMS, if we combine this mass bank as well as met react, these two, then you may be able to know the molecular formula, the spectra, everything. As you can see, experimental comparison, when we are comparing with that, the experimental, we are comparing with the standard, this blank one, those without having any exposomics, mass bank. Okay, so combined, we are giving this one. So this is the way how we are going to identify the presence. So this is general strategy, workflow strategy, exact mass, how we are identifying this particular software. Just remember, serious software is used to mainly know the presence of isotopes, right? So these are the procedure how to identify their presence. Some of the compounds identified in dust and hand wipes. Some of the contaminants or exposomics like tertiary butyl triphenyl phosphate, tricresyl phosphate, V6, dodecyl sulfate, hexadecyl sulfate. So these are the many main compounds which are able to be identified as exposomics. Okay, so and this is the main procedure how to identify the presence of your exposomics in the environmental sample. This is a very important thing required nowadays to check the pollution, to check the people from contaminations, because those contaminants, when they will be entering to your body, they may cause some diseases, they may cause some disorders, they may cause some disturbances in your body. So that is why if we'll be able to identify their presence, then we can check the pollutions, we can check the pollution. So this is all about my talk. And last, I want to thank Coalesce Research Group, United States of America, for inviting me this third international conference on mass spectroscopy and analytical techniques. So thank you. If any question will be there, I'll be happy to answer. Thank you.
Thank you, Doctor. Is anyone having any questions? Thank you, Dr. Atia, for your presentation. Does anyone have any queries?
Sorry. Hello. Any question?
Hello, hello, hello.
Yes.
This is Ebu Kafka.
Sorry.
Yes, I connected already.
Sir, I'm not able to hear you.
Didn't you hear me?
No, 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 no. Please, can you speak loudly? Hello.
Hello.
Yes, please.
I think there are no questions. Thank you, Doctor, once again for your presentation and presence, Dr. Nalin.
Thank you. Thank you. Thank you very much.
Thank you. Let's move to our next presentation by Dr. L. Palaniappan from Annamalai University, India. Doctor, are you ready with your presentation?
Yeah, madam. Right.
Okay, now I'm going to make you as a presenter now. Please share your screen.
निधि मैडम है एक बार बोलो हो गया सबका एक बार निधि मैडम
Hello. Hello. Am I audible? Hello.
Yes, Doctor, you're audible. Please continue with your talk.
Fine. So it's my pleasure to participate in this familiar conference. Of course, I'm delighted to take in basic science research. The presentation is regarding the influence of carbohydrates, like fructose or glucose in the
निधि मैडम
interaction profile.
प्रसून सर
Hello.
पे हो गया एक बार पूछ लीजिए जो टाइम टेबल टेंटेटिव टाइम टेबल बना रहे
Hello. Next one is hello.
Yes, Doctor, please continue with your talk.
So it's the analytical studies on the effect of fructose on the interaction profile of proalbumin as well as lactalbumin. In another part, I use a Laplace transform study in fixing the solvent profile. So the basic aim of the thing is that problem which we have taken, is the denaturation studies of proteins. Proteins normally have four different types of structures. In general, normal protein is having primary structure, and your protein is supposed to have all its viable strength in its native state. Native state means its natural state. But when it is subjected to some denaturation agents like pH, variation in pH, extreme pH or extreme temperature, if you change the ionic strength or the solubility ratios, then automatically protein will denature. Denaturation is basically a loss of biological activity. What are the benefits which we are expected from a particular protein may not be available if it is in denatured condition. So, if a protein is consumed, it should be always taken care to be in its native state. But native state protein cannot be assimilated as such, cannot be taken as such. It has to be cooked, it has to be taken in a different form. So, normally the cooking process or the food processing techniques in most cases will make the protein to be denatured. It will make the biological activities to go up. So we have to find the methods to retain its biological activities. That is to make the denatured protein to be in a renatured condition. Or in general, what they so we shall see. I have taken one hypothesis here. The denatured protein is taken if it is along with a sugar or salt or any additives, then it will become a natural protein. That is the hypothesis I have taken. So the problem is the problem and assumption both are given in this slide. Normal protein in a cyclic manner subjected to some cooking process make it to denatured condition. In the denatured condition, if we like to remove it, then we have to some additive. You have to add some additive like salt or sugar, then it will bring back to a normal protein condition. Of course, not totally, but mostly. So the main thing behind the work is whether we can consume the proteins, any protein with additive or without additives. That is answered in this work. So I have taken the oval albumin, the egg protein, especially the yellow part, and the lactalbumin, the protein is available in milk. Of course, both are having so many proteins.
ନାଇଁ ନାଇଁ ସେ ମେନ୍ କଥା ଆମେ ପ୍ରି ନର୍ସରୀରେ ସେ ଭୁଲରେ ଆଡ୍ କରିଦେଇଥିଲେ ତ ସେଇଥିରୁ ସେମାନେ ରିମୁଭ୍ କରିଦେଲେ ନର୍ସରୀରେ ତ ଅଛି ଆମେ ତମ ନା ସେଇଥିରେ ଆଡ୍ କରିନାହାନ୍ତି ଇଭିନିଂ ରେ ସେ କଥା ହବ ଗୋଟେ ମିନିଟ୍
Hello. Okay. So the samples which we have taken in the studies are oval albumin, lactalbumin, and egg protein, and one milk protein. I have not taken all of the proteins. Just these two are globular proteins. I have taken only globular proteins because they are simple, they are easily miscible in water, and they can be easily processed, and they are mostly taken in the day-to-day life activities. So we have taken only these two proteins, and similarly the additives, we don't take any salt. We have taken only fructose and glucose. These two we have taken. Both carbohydrates are almost similar in structure with a change in structural formula. One is ketone group, and the other one is another group. And the methodology we use are the ultrasonic studies and the FTR studies. Using sound velocity profile. The sound velocity profile using the basic parameters like density, viscosity, velocity, and other things. These are the measured parameters under ultrasonic studies along with surface only by droplet method. And plus two more calculated parameters like adiabatic compressibility, free volume, free length. They are also giving some good idea about the functional properties. And in addition to the ultrasonic profile, we have taken the FTR studies. So in FTR, I have taken only the secondary analysis just to analyze the structural compactness of the proteins with and without glucose and fructose or the sugars. So these are the parameters we have taken in ultrasonic techniques. One is the ultrasonic velocity measured by interferometry technique. The second one is the density using specific gravity bottle. The third one is the viscosity by viscometer. The surface tension by dropout method using platinum dowering. Whereas the calculated parameters include derivative compressibility, intermolecular fueling, specific impedance, relaxation time, and few more. And the partial apparent specific volume, partial apparent specific compressibility, relative specific sound velocity. All these are calculated parameters, and we have to verify whether all these parameters are in coincidence with one another. So these profiles give the functional properties of the protein along with the carbohydrates. And the protein we have taken, one is a normal protein, that is the protein as such we purchase from sigma aldrich. The other one is a reduced size protein, where we are using the size reduction technique just to boil its, rise its temperature around 85 degrees centigrade for ovalbumin and 60 degrees centigrade for lactalbumin. The size can be considerably reduced. The size has been verified by dynamic light scattering experiment, DLS technique, and it is found to be less than 100 nanometers. And to choose whether normal protein or nanoprotein is which one is better, that we have taken reading for both. We have compared the values and found the values are consistent for nanoprotein. So the work is only with the nanoproteins. And for the ovalbumin, the graph shows the variation of 5V, that is apparent specific volume, that is buffer plus ovalbumin system, and buffer plus ovalbumin added with the glucose system. Similarly, the other parameters, buffer plus ovalbumin, specific adiabatic compressibility. Usually, compressibility indicates the ease with which we can compress the system. If more space is available, it means the interactions are very poor. So here, for a nanoprotein, the 5K values are very low, means the space is very less, and it indicates a compact structure, very compactness among the components of the system. So this diagrams clearly shows that the nanoprotein particles are the better choice for the work in progress. So we have chosen nanoparticle system and do the complete ultrasonic analysis. So for density for buffer alone, buffer plus ovalbumin, B plus O is buffer plus ovalbumin, buffer plus lactalbumin. Two proteins we have taken. Proteins along with the buffer only. Then proteins with the carbohydrate only, glucose and the fructose. G for glucose and F for fructose. Similarly, glucose added with the ovalbumin, glucose added with the lactalbumin, fructose added with the lactalbumin, and same with the oil. So all these are the various systems we have taken. And for various systems, we have chosen the pH to be 2, 5, 7, 9, and 12. 7 is the neutral pH, whereas 5 is the PI value. 4.8 is the PI value for ovalbumin. And 2 and 12 are extreme pH that we have taken as the denaturating agent. The extreme pH, the values can be seen to be largely deviating from the original value. And then adding with the glucose. Suppose you compare the B plus O with the B plus O plus G and the B plus O plus F, values are found to be improving. That is, it indicates the system is approaching towards a native state if the fructose or glucose are added. The first time, the very first row, pH2 is there. For pH2, for the system of buffer plus ovalbumin, the value is around 1045 kilogram per meter cube. Whereas for buffer plus lactalbumin, it is 1022.6. But the same, if a carbohydrate is added, say a glucose or fructose, value is improved to 1088 and 1090. Sound velocity is having enormously increased. Increase in velocity, increase in density means a compactness of the system. Compactness is a regaining of native state. So the density parameter pH2 disturbs the state or structural state of the ovalbumin as well as lactalbumin. Whereas the addition of salt seems to improve its states. The same conclusion, same type of conclusion is available in sound velocity. Again, sound velocity is a measure of cohesion process among the components. The same thing is true in sound velocity also. In pH2, sound velocity is poor in buffer plus overall domain and buffer plus lactal domain, whereas it is enhanced in the addition of glucose or fructose. Same thing is true in all the cases. We have got a concurrent values in all the measured parameters. Viscosity has to decrease. That will indicate the compactness of the system. So we have a compact system if a carbohydrate is added, yes, sugar is added. That is unanimously obtained in all the measured as well as the calculated parameters. Calculated parameters, we have the graph. Graph indicates a very good relative association among the components if sugar is added. So this unanimously indicates the addition of sugar is improving the structure of proteins. That is one by one, the secondary structure is moved to primary structure or the native state. When the structure is regained, it indicates a renaturation state of the proteins. Now coming to FTR analysis. FTR analysis, we have taken only for second derivative analysis. Second derivative is done by origin program. First, the primary spectra is recorded. From the primary spectra, we have taken only amide 1 region. Amide 1 is between 1600 to 1700 per centimeter. That is amide 1 region. It is normally taken in the case of proteins. That region is more sensitive for proteins. So we have taken only the amide 1 regions. What are the data available between 1600 and 1700 has been taken as an input in origin program, and the second derivative analysis is made using least square method. The second derivative spectra has been constructed. See the second derivative spectra here. So this is primary spectra. This is primary protein. Secondary structure is having random coil, alpha helix, beta sheet, beta term. All these are secondary structures. Whereas in primary structure, these things are not available. In secondary structure, the quantity of alpha helix or beta sheet indicates the strength in the structure. So alpha helix and beta sheet structure will be like this. Beta term and random coil. These are available in minimum quantity in all the proteins. So taking the second primary structure, primary spectra, the one is buffer plus overall albumin, the other is the buffer plus overall albumin with the glucose. Now we have to construct the secondary derivative spectra. The lower one is the buffer plus overall albumin, whereas the upper one is with the glucose. With the glucose is having many different new peaks that are unanimously regained by the addition of glucose, and all the peak assignments are given. This is for pH2. For every pH we have taken, we have constructed the secondary derivative spectra. For all the spectra, peak assignments are given, and they are compared with the standard literature. And the total area assigned under each structure is measured. They have been given total area is has been calculated for without co-solvent and with the co-solvent. The glucose or fructose is taken as co-solvent. For pH2, the area available for beta sheet around 1615 is 5%. For 1622 is 5%. Like this, for every wave number, we have taken we have calculated the area, and the assignment has been given by comparing the literature, and the consolidated value we have taken. From the consolidated value, we have to conclude this is the consolidated qualitative measurement. Without co-solvent, alpha helix is 18, whereas with the co-solvent it is 23. But for beta sheet or pH2 it is same. The increase in alpha helix may be taken as a regaining of structure, whereas the other one is the denaturation structure. So the consolidated statement confirms the addition of glucose or fructose, or in general the co-solvent. The addition of co-solvent improves the secondary structure, and thereby it is confirmed that the protein have regained their original state if sugar is added to it. It is called alpha lactal. So these ultrasonic and FPR studies both confirm that the addition of sugar is increasing the structural stability, whereas the other one is deteriorating the structure. So that's the conclusion we have obtained by the addition of sugar component. Sugar refers to glucose as well as fructose. And now the other problem in this is we are using buffer and the co-solvent. Buffer is a solvent, and we have taken glucose or fructose as co-solvent along with the protein. So the system is a multi-component system, and with which component the protein has a priority. That is another problem we have addressed in this one. So we are now going to that problem is addressed by Laplace transform technique. All these are secondary structures we have used in this. So now taken to a Laplace transform technique, which is a Laplace transform generally indicates a transformation from one branch of mathematics to another branch of mathematics. Usually, any process, maybe in basic science or natural science, has a mathematical interpretation, mathematical equation. That mathematical equation can be changed to another form of mathematics. Normally, we use calculus to represent any physical process. That calculus equation can be transformed to algebra equation. First, to get a easier calculation, the estimation of a value, if we use algebra equation, will be easier than using a calculus equation. So calculus equation as such cannot be used to get the numerical value, numerical answer. So if you like to have a numerical value, so calculus equation may be transferred to algebra, and then on substitution of the variables, we can get the final value. Based on this purpose, we have applied a Laplace transform to change the calculus equation to algebra equation. Fine. Here, we have taken the process of dissolution of protein in solvent or co-solvent as a diffusion process. For example, in physics, if it is electric potential, the equation is dV equal to F dot dx plus minus F dot dx. Whereas the current is given by dI equal to I naught d sin omega t. All are calculus equations. Similarly, for diffusion, we have equation del square U equal to 1 by k into dou U by dou t, where k is diffusivity. That diffusivity we have to calculate and we have to substitute. And this diffusion equation is a calculus equation. This equation cannot be used to get a numerical value. So we have applied the Laplace transform to change the diffusion equation, the diffusion process. It is a slow spreading process. And we have changed the diffusion equation to a Laplace transformed algebraic equation. The first one is the diffusion equation, del square U equal to 1 by k into dou U by dou t. Whereas U of x comma t equal to U naught of 1 minus 2 by root 5 x by 2 by root kt, etc. with the higher orders. This is the algebraic equation. In algebraic equation, x and t are variables. X is the distance or the space, and t is the duration, time. U naught indicates the original concentration of the protein. U indicates the dissolved protein. So the dissolved protein, which is a function of x and t, distance and the time, will be given by U naught, the amount of original protein taken, into 1 minus 2 by root 5, all are constant except k. K is the diffusivity. Diffusivity we have to calculate from the knowledge of density and viscosity again. And substituting the respective values, we can theoretically calculate diffusivity, from which the diffusion coefficient have been substituted, and finally the C1, C2, the constant have been substituted with the error function analysis. We have to minimize the error in the calculation along with the error function analysis, and finally the calculated tables have been given. This table shows the different solvent available in the system and their respective density, viscosity, and the molar volume V. All these three are required for the calculation of diffusion coefficient. These are standard values we have taken from literature. Using the standard values, we have to calculate the binary diffusion coefficient, DAB. The binary diffusion coefficient has to be substituted for determining the multi-component diffusivity. Here the multi-component diffusivity is DI mix of protein in various solvents. The various solvents are water, monobasic, dibasic potassium, phosphorus, and phosphoric acid, sodium hydroxide. So phosphoric acid is used for pH 2 and pH 5. Sodium hydroxide is used for pH 9 and 12, whereas fructose and glucose are for two co-solvents, and monobasic, dibasic are used for the preparation of buffer. Here we are using potassium buffer. So monobasic and dibasic potassium phosphate as we have used, and for each solvent, how much protein has been dissolved in each solvent. Water is a solvent, monobasic potassium is a solvent, dibasic is a solvent, phosphoric acid is a solvent. Like this, in each solvent, how much protein has been dissolved, and then finally total amount of protein dissolved is 1.535 into 10 power minus 6 kilogram has been calculated. Using this formula is obtained from Laplace transform. The Laplace transformed equation is used for calculating the dissolved proteins. So this is done for overwhelming system as well as lateral system. And the bar diagram has been given. The bar diagram shows that three different variations are there. The blue color indicates without co-solvent, whereas the brown color is with the fructose, whereas the green color is for with the glucose. In general, if there is no co-solvent, then the diffusion is very low, very feeble. That is, protein is dissolved in buffer to a very little extent. Whereas if you use a co-solvent, then the dissolution of protein will be very high. It is maximum for fructose, whereas not so for glucose. However, glucose and fructose have a considerable dissolution. So this bar diagram confirms that the fructose or glucose, that is an organic compound, can dissolve the protein, which is again an organic compound to a maximum extent. Whereas buffer is an inorganic compound. Inorganic compounds don't dissolve to such an extent. So the general concept of like dissolves like dissolves like is again confirmed in this study. And that's what we like to confirm. So this study concludes that the addition of the co-solvent or the addition of sugar or salt with the protein during cooking process will enhance the biological activity of the protein and can give enormous benefits of protein use. And further, the additive should be preferably an organic additive. That's what we have concluded in this. So with this, we have got the unanimous conclusion. As I said just now. And the further steps we have mentioned that the same analysis can be done for other proteins of again milk. We have taken only one protein from milk, and we are concluding especially for that type of protein. Same can be extended for other proteins available in the same samples. Similarly, other co-solvents and also some salt, they can also be tried up. So that's what the proposal is considering. With this, I like to conclude. I like to thank Coalesce Research Group and the organizers for making me a part. So thank you. If there be any questions, please.
Hello.
Hello, yes, madam.
Doctor, are you completed with your presentation?
Yeah, I have completed. Is it not audible?
Okay, thank you. Yeah, at the last, we didn't heard that you have completed your presentation. It's okay. Thank you for your presence and presentation. Is anyone having any questions? I think there are no questions. Let's move to our next presentation by Dr. Shiva Subramanian from
Yes, madam.
Dilkap for Engineering and Management Studies from India. Doctor, are you ready with your presentation?
Yes, madam. Can you hear my voice?
Yes,
Can you
I
hear
can
my?
hear your voice. Now I'm going.
Please.
Yes. Now I'm
Yes.
going to make you as a presenter now. Please share your screen.
Yes, madam.
Yes.
Just a minute. I will share it.
Okay.
Can you able to see my screen?
Yes, we can see your screen. Please continue with your talk.
Okay, madam. So, good afternoon to everyone. So, my name is Shiva Subramanian Pallisamy. I'm working as a associate professor in the Department of Mechanical Engineering at the Dilkap Research Institute of Engineering and Technical Management Studies in Maharashtra, in India. So, as well as I'm working as a researcher in the Department of Mechanical Engineering, Kalasalingam Academy of Research and Education, Krishnagoil at Tamil Nadu. So my main topic, the presentation main topic is mechanical property of chromium 10X reinforced natural rubber composite. So here, the chromium 10X is one of the natural fiber. There's the leaf fiber. From the leaf fiber, we are extracted the fiber. From the leaf, the chromium leaf, we are extracted the fiber, and as well as this the chromium 10X is a natural fiber at the same time. So I have reinforced with the natural rubber composite. So you know that especially in Kerala, especially in Kottayam, there is a more available the natural rubber. So I was working over there, so that's why I choose this natural fiber, natural rubber, as you're reinforcing with the chromium 10X fiber. So my objective of this study, this work is concentrate on the possibility to apply these fibers in different amount and cut to different length as the filler for the natural rubber composite, a possibility that has received little attention so far. So in this chromium 10X fiber, very little attention data, all the things are available in the reinforced with the natural rubber. So that's why I started working on that chromium 10X fiber reinforced with the natural rubber. So actually, this is the chromium 10X fiber leaf. So in this leaf, leaves were collected in the fields around the Tamil Nadu in India. So after collecting, so we cut we are cutting close to the root, which gave the leaves between 0 to 80 centimeter long. So they were immersed straight in the container of water with a capacity of approximately 20 liter, which was filled with the tap water for 30 to 40 days for extracting the fiber from this leaf. These leaves were not exposed to sunlight, rain, as well as wind during the period to reduce the variability of the fiber properties. So nearly 30 to 40 days we are keeping the leaves the filled tap water. So approximately we are maintaining a 20 liter, as I said earlier. So if you are maintaining 30 to 40 days, definitely some amount of the content of the water will be reduced. So to avoid the reduce the water, the water was often added to maintain its level. So we are maintaining the 20 liter of water. So the leaves were regularly absorbed. The fibers were then separated from the leaf by stripping as a whole. Then separated from the leaf by stripping as a whole, the represented over 70% of the weight of the whole leaf. The remainder, the weight being due to loosened part to protective waxes. So this is the from the leaf. So after, so before extracting, the initial appearance of the leaves after drying. So after the second, this diagram is, this figure is the appearance fibrous material after stripping. This is the before stripping, this is after stripping. So here, before knowing about this this thing, you're supposed to know more than that about the extraction. The fiber were then washed again while combing under running water. So why we are doing that combing under the running water? To avoid the formation of knots on the fibers. So while we are extracting, the knots should not be there in the fiber. So that's why the fiber were washed again and again. So while combing the under running water. Okay. So finally, we are drying for a few hours under the sunlight. Okay, for drying process. So initial appearance, the first initial appearance, the leaves are represented in the A figure, leaves after drying. And final appearance, the fibrous material is reported in the second figure, the B figure. Once ready the exact without getting the knots of the fiber, we are measured the length of 6 mm, 10 mm, and 14 mm using the scissors with a measured accuracy of plus or minus 0.1 mm, maybe will be there. So while cutting the fiber, some of these fibers were collected to the observed under the optical microscope to evaluate the morphology. So in this optical microscope figures, so I have shown in the future slides. So these are the chemical, what are the chemical I used for making a fabrication of this chromium 10X reinforced with the natural rubbers. Initially, the ingredients, what are the things are the natural rubber, stearic acid, zinc oxide, TMQ, CBS, the sulfur, and untreated chromium 10X fiber. So here I have shown that the combination, what are the combination I have taken to proceed my work. Okay. So by using that, by using those the chemicals and the ingredients, we have to make a fabrication. Okay. So normally the polymer composition, what they will use it, so they will make the molding box, they will make the concerned resin accelerator catalyst. The record the fiber have to cut the fibers and mix with the resin accelerator catalyst, and they will put it in the molding box. Same like that, here I'm showing this the two roll mill. Okay, by using this two roll mill only, we are mixing all the ingredients. The first of all, the natural rubber, stearic acid, zinc oxide, TMQ, CBS, sulfur, and a chromium 10X fiber. So those things, everything we are mixing by using this two roll mill. Okay, so this roller diameter is 150 mm, which I showed here. Then face width, the face width is 300 mm. So here the inside the motor is fixed. So because of that motor only, the roller is rotating. The motor, the power is 7.5 HP horsepower. This two roller milling machine is two roller machine is working in the 1440 RPM. The batch capacity is 3 kg, and the reduction gears is 40:1. So here the necessity of the quantity of were added to the small opening between the two rollers. Small opening will be 1.5 mm. So those values were selected to increase the fiber orientation in the mill direction. Okay, so here fiber was combined with the rubber in the laboratory with the two-roll mill mixing. So while that the dimensions of the material after mixing, the 150 cross 300 mm dimensions with the friction ratio of 1:1.25 is that is the according to the ASTM standard 3184/80. The mill opening is 0.2 mm. The dip gap, mill roll speed ratio, as well as the number of passes have been stored identical in the all combinations. All combinations with what I said that the pure natural rubber, the P1, P2, P3. So while the fiber were incorporating at the end of the blending process, here the blending process will be happen during the blending process to avoid the breakage. So in between this two roll, there are two rolls are there. In between two roll only, we are putting all the ingredients along with the rubber. So while we are putting the fiber in between that, along with the all ingredients, we are putting the fiber as a record length of the fibers. Definitely some breakages will be there, will be happen. Okay, so blending process to avoid the breakage of the fibers that are taken care of the maintain the direction of the flow of the compound, so that most of the fibers are aligned in the grind direction. The samples were grind sufficient time to dispose the fiber in the matrix at the mill opening is already I said 1.25 mm. So later on we are completed the mixing. After completing the mixing, the stoke sheet was pulled out. The roller sheet was passed through the 0.2 mm tight dip gap. So earlier 1.25. So after completing, definitely the roller sheet was passed through the 0.8 mm tight dip gap at the end of the lap of 6 to 7 times, and finally the left 3 mm dip gap will be there. So the concern, the thing is, this is the aspect of the compound before curing. So immediately when you are taking out of that the two roll mill, so immediately we will get like this. Okay, so in this thing, from this thing only we are cutting the specimen, molding the test specimens. The test specimens to determine the physical property like a tensile, tear, hardness, abrasion were prepared in the unheated mold by compression molding on electrically heated hydraulic press plate with approximately 450 mm side of the pressure of the 200 kilogram per centimeter square with 2.5 mm thickness of the specimen. The rubber compound were vulcanized at 150 degrees Celsius. So that is our wish. So we can carry the 150 degree or 160 or 175. Okay. So based upon the researcher, based upon their work. And the mold material was immediately cooled in the running water, kept in the cold and the dark for 24 hours, and used for the subsequent physical tests. Okay, the physical tests which I mentioned, the tensile, tear, hardness, and abrasion. So those are this is the abrasion tester. So here, so I mentioned earlier, like nearly 2.5 mm thickness will be there. Okay, so for others means the tensile, tear. Okay, so hardness, definitely the diameter should be 40 mm. Then abrasion resistance, it should be more than the 6 mm thickness should be there. Here 5 mm thickness for hardness, the 2.5 mm thickness for the tensile and the tear. So this one is here. So already I told you the optical microscopy, the morphology. I said that the future slide I will show it. So this is the chromium 10x morphology. The optical microscopy transfers observation of the cross section. So the chromium fiber morphology is observed that the optical microscopy transfers observation of the cross sectional area along the line of the methods. These images suggest that the typical structure is as a collection of polygon cells for which the shape is not for removed from the quasi hexagonal section characteristic of the flax fibers. So here we can able to see that the four shapes are there. Among that, but I have shown that four morphologies, the optical microscopy morphology shapes, the four images. If you are looking at, we can able to observe that there are four shapes are tentatively identified. Okay. Also based on the previous studies, the elongated first one is elongated. The second one is a quasi-circular. The third one is a same like a horseshoe. The fourth one is we can say that the keyhole. So those things I observed from the optical microscopy images of chromium 10x fiber. So in all these, the presence of lumens appear to represent the considerable portion of the whole sections. Okay, this added to the fact that most fibers have a section with a quite distant geometry from the circular one. Okay, so from that, I'm suggesting it is suggested that the significance of the possible error in the evaluation of the tensile strength of the composites. Here, this one, the analysis over fiber breakage. So as I said earlier, we are using a two-roll mill. In between, we are putting the fiber along with the rubber as well as the chemicals. So while we are mixing all the things, definitely some of the fiber will get damaged. So this breakage analysis I have taken. So here 6 mm, 10 mm, 14 mm. So when you are putting the fiber, the corresponding the length of the fiber in the the two-roll mill, definitely due to the breakage analysis, so few of the things will be breakage. Okay, so from this, the fiber diameter hardly change during the process, definitely, especially if the natural fibers are sufficiently very hardened one. Okay, this result of the fiber breakage, which I reported in this figure, which is indicated that of the 3 fiber lengths used, the shortest one is a 6 mm, then suffer the least fragmentation, while the longest one is a 14 mm. Was basically always reduce the length by the processing. So for this reason, the verification in the subsequent experimental work was suggested to examine whether it was possible to increase the amount of 6 mm fiber is introduced in the composite, or else if the advantage obtained from using the longer fiber 14 mm, the longer fibers would be justified. The longer fibers may be 10 mm or 14 mm, the comparing to the 6 mm fiber. Okay, the longer fiber would justify a future intervention of the processing to make it more suitable for the introduction of chromium 10x fibers. So this is so after making the specimen, after analyzing the breakage analysis, we are moving to the tensile curves, the different category of samples. Okay, so from this figure, the possibility of the tensile performance, I have shown the tensile performance of the 6 specimens. The natural rubber, only 6 mm, then the P2 strength rubber, 6 mm, 10 mm, 14 mm, then the maximum. Okay, so which this figure is typical curve obtained for the 6 series specimens is illustrated that all the cases of considerable decrease the tensile strength. Okay, so decrease the tensile strength is obtained with the respective to the pure rubber. It is also likely that the strain induced crystallization, which can be produced the increase in stress above the certain deformation level would be equally will be reduced. This should be take place as the effect of the disruption produced in the structure of the rubber molecules by the introduction of the chromium 10x fibers. Okay, so this phenomenon is also attributed to the attraction between the polymer molecules as well as the fillers, as it is normally observed in the natural rubber composites. So, however, the dimensional variability of the chromium 10x fiber also result in the higher difficulty possessed by the matrix slide with the respect to the fiber once the strain produced on one set of the defects in the at the interface. Okay, so this is the tensile strength graph. Tensile test in the tensile strength, the elongation, as well as the 100% of modulus. Okay, so here I have taken all the values on the average as well as the standard deviation of tensile strength, elongation, as well as the 100% of modulus. If you are looking at the A figure in particular in terms of the tensile strength is only option comparable with the natural rubber is inserting 10%. So here already I have shown that the formation table 10%, 20%, 30% I have that. So here 10% of 6 mm, the long, the chromium 10x fiber. When you're coming to the B, the second figure, this composite is also one of that bears considerable elongation higher than the pure natural rubber. Okay, so here the possibility to increase the amount of fibers introduced for the higher stiffness also appear to the interest. However, this considerably reduce the elongation of the composite to the point that with the introduction of 30% of 6 mm, the long fiber, which I shared that P3, the strain introduced crystallization, I mean SIC, is affected so that some cases even 100% deformation is not reached before the rupture. When you are looking at the C, the third figure, the third image graph, as a consequence, the highest stiffness is only reached with the considerable scattering of value. And therefore, the limited predictability of the behavior will be occurred in this third figure. This effect can be correlated possibly by the scarcely effective stresses transfer across the interface between fiber as well as the matrix. Here we are taking as a matrix as a natural rubber. So probably due to also to the irregular and variable surface grips will be happen in the chromium 10x fiber. If you are looking at the other side, using longer fiber, here the using longer side means the longer fiber means less fiber, less length of fiber means 6 mm, the longer fiber means 10 mm or 14 mm. Thus gradually increases the modulus with respect to the same amount, 20% of 6 mm long fiber, as can be seen by comparing the performance of P2. Here P2 means the 6 mm, 10 mm as well as the 14 mm as composites. It may be suggested that it is difficult to maintain the straight alignment of chromium 10x fiber at a higher length. So now the tensile thing is over. Now I'm coming to tear strength. So when you are looking to the tear strength from this figure, so what I observed is it is also possible to the first figure. It is also possible to consider that the higher amount of the 6 mm fiber can be also be beneficial for delaying tear fracture, although possibility to make a performance less controllable. The same way, if you are looking, since indentation during the hardness test produce a distinct tear effect, the same effect was revealed at the B, which suggested that opportunity for the possible introduction of longer quantity of the short fiber, although it will make a process more difficult and the curing time will be longer. Okay, so another possibilities are there, like the criticality of increasing the fiber. When you are increasing the fiber content, as shown in that they're dealing with the abrasion resistance. Abrasion resistance measured in a centimeter cube per hour, the similar to that from other studies on the rubber example. So here no real benefits appear when tripling the amount of 6 mm long fiber in the composite from P1 to P3, as I showed that figure 3. I will see. Based upon that, so the suggestion for this behavior can be possibly linked to the fact that the longer presence of chromium 10X fiber may be also result in the agglomeration. If it is not happening, the formation of the complex entanglement in the composite, this is the frequently observed the fiber with the high cellulose contents. So these are the things, the result of all the properties at tensile strength, tear strength, the modulus, tear modulus 100%, 200% and 300%, as well as the tear strength, Soria hardness and abrasion resistance. I have shown over here all the 6 specimens. Natural rubber, the P1, the less length of the fiber, the 6 mm. Then P2, the 6 mm of fiber length. Other P2, 10 mm of fiber length. Another P2, 14 mm of fiber length. And the P3 is the longest fiber. Okay, here you can see this, the one. Here I have mentioned that P3, I have mentioned that not reached by the all samples. I mean 3 out of the 5 for 100%, and none of for 200 or more. Okay, so also I have studied the comparison between some tensile result of this the chromium 10X as well as the some other studies also. I have shown here other fiber like a jute, sisal hybrid, sisal and oil pump hybrid, banana, bowstring fiber, the hemp, bowstring fiber hemp, the hemp, the chromium 10X. Okay, based upon that, the number of natural, based upon that, so what I observed is the number of natural fibers are able to preserve high elongation in rubber due to the what is happening, the strain induced crystallization. In terms of stiffness as well as the strain, the chromium does not always comparable favorably, which can be again ascribed to its irregularity with respect to the typical textile fibers such as jute, hemp, and also or sisal fibers. If you are looking the other hand by using this, if you are looking the other hand, it is a fiber widely available that the grows easily as a weed, and is also needs to be often disposed of for gardening and maintaining for the purpose. So based upon that studies, here I am concluding. So what are the things I concluding is, in this present study, the aim to develop the eco-friendly composite material specimen developed from an analysis of mechanical properties. The biodegradable composite specimen of these studies is the fabrication composite by chromium 10X fiber along with the natural fibers. So third one is the properties of the specimen were compared with a different length as well as the weight fraction of the fibers. It has been established that by strengthening natural fiber rubber with a natural fiber, the tear strength, hardness, and abrasion losses may be significantly increases. From the fabrication part, from the fabricated composite specimen, it was speculated that the composite exhibits the best desirable properties, and the fiber length is 10 mm. Furthermore, the introduction of the higher fiber loading, such as 30% of fiber per 100 parts of rubber, 100% of natural rubber, also bear some interest in the view of an improvement in hardness. Although it conversely appear to seriously reduce tensile elongation. The critical issue here, the critical issue appeared in the possible processing, especially in view of the proposing the possible application of these composites. However, whenever the higher hardness is required, example, higher hardness would be like example like the brake shoes, the vibration resistance screws, oil seals, and the gaskets, all the things. Definitely, the higher hardness should be required. So the economic advantage obtained is due to the fact that the chromium short fiber is used for this purpose of obtained at no cost as waste from the textile, and as well as especially the rope manufacturing. Further, evaluation would be centered to elucidating the combining with rubber compound as that the degree of. So these are from the references. Thanks for patience. So really, I'm very happy to present, share my studies with you. Allow
Thank you, Dr.
through
Shiva
the
Subramanian.
international webinar. Really, I'm very happy to say thanks to everyone, the participants. Please, yes. Sorry, I didn't get you. Sorry, hello.
Thank you, Doctor, for your presence and hello. Thank you, Doctor, for your
Yes, sir, madam.
presence and presentation. Is anyone having any
Okay.
questions?
Yeah, tell me.
I think there are no questions. Thank you once again for your presence and presentation. Let's move to our next presentation by
Thank you.
Dr. Siddique. Yep, thank you. Rajashari University, Bangladesh. Doctor, are you ready with your presentation?
Yes, I am Dr. Siddiq. Do you
Yes, now I'm going to
listen
make you
my
as a presenter now.
now? I am now shared the start.
Yes, we can see your screen.
How can I share?
Please click on yes. Can you minimize this GoToMeetings app and open your PPT presentation?
Okay.
Yes, we can
Yes.
see your screen.
This is see the screen.
Yes, so
Yes. Says I am Dr. Nur Alam Siddiq.
Dr. Siddiq, can you please make it as a full screen or else rotate your screen so that we can see the presentation clearly because
Yes.
in the
Uh,
phone we are
do
unable.
you see the screen and sound?
Yes, yes, screen
Yes.
is okay and we can hear your presentation
Yes.
and also I request
With
you to keep your display rotate into landscape. Can you please make it your screen landscape? The
screen.
presentation we are we are unable to see clearly. That's the reason I have asked you.
Uh, then I will display and and speaking details. Then you will see the and
Okay,
understand
please
the my presentation. Yes,
continue with
I
your
am
talk through this
continuing my talk.
telephone and
Yes,
and I request everyone to zoom in the presentation so that you can able to see the presentation clearly.
yes.
Thank you. Doctor,
With
please
best
continue
respect,
with your talk. Thank you.
first and foremost, gratitude to Almighty Allah for countless blessings. It is deep to gratitude to pleasant duty to express my obligation at third international webinar on mass spectrometry and analytical techniques 222 for permission me as a speaker. As I have no previous correspondent to you, let me understand myself. I am Dr. Nur Alam Siddiq, serving as a Principal Scientific Officer, Metal Agro Limited, Bangladesh. I am plant biotechnologist operating a tissue culture laboratory, potato seed production, mini tuber, uh, mini tuber breeder and foundation and certified seeds, and also sale and marketing. Metal Agro Limited, one of the largest seed companies of Bangladesh, quality inbred and hybrid seeds, vegetable and rice, etc. Along with potato are produced with their own management. I am also expressing my obligation to our Honorable Managing Director, Dr. Shadid Jamil, MD, Metal Agro Limited, for sponsoring all facilities of my research. Research title, Lead Blight Disease Management of Potato. Subtitle, Comparative Efficacy of Different Fungicide Against the Lead Blight Disease on of potato incited Phytophthora infestis and standardize the dosage for its management. Introduction. Bangladesh is mainly an agriculture-based country. It is a thickly populated, a small country with an area 4.48 million hectare land, according to the estimated of Bhuya 202 net cultivable land would decrease gradually due to increasing the population. Considering the trend of population growth and consequent the increase the demand of food in the country, and during the cultivable land area showing the production status past few years. Here the table, the data of production of potato and the land area and production per hectare in ton. In 220 to 213 to 14 years, the total area of production 11 lakh to 41,000 acre, and the production 8 lakhs 89 lakhs and 50,000 ton. This is the sequence. This is the most. This is the most production in the 260 to 207 years. Here, the production are 1 lakh to 1 course and 2 lakhs and 60,000 ton, and the production in per hectare land in 200 2.5 3.5 ton. This is the next slide. Bangladesh is predominantly agricultural country. Agriculture is the independent indispensable culture of Bangladesh. Bangladesh has an incipient contribution to the gross domestic product of Bangladesh. Earlier, more than 50% of the GDP comes from this sector. According to the Export Promotion Bureau of Bangladesh, earned the following currency from the foreign exchange. In 204 to 209 years, Bangladesh earned 1,86,892 dollars. In 209 to 210, 34 lakhs and 54,000 and 651 dollars. Bangladesh earned. Lastly, 212 to 213, Bangladesh earned from foreign currency on code 9 lakh 30,000 and 62 dollars. The source is collected from the Bangladesh Bureau of Statistical 209 to 213. In the above discussion, it is clear that potato plays an important role in our economy. Though rice and wheat are our main food crops, their production is not sufficient to meet the increasing the requirement for the growing population in the country. In this regard, potato can play an important role as an alternative and a multi-purpose food crop in Bangladesh. It also important cash crop for the farmer. The current potato production in Bangladesh appear to be adequate to meet the domestic demand for potatoes in household consumption. Bangladesh is now 14th among the world potato production producer and fourth last in Asia. potato production was 24.66% in the total all production of the rice, wheat, and potato. Some plant disease that can completely destroy plant potato plots. Lead blights are one of the devastating fungal disease that attack to potato field and completely destroy if any preventive measure cannot be taken from beginning of initiated the lead initiated the lead blight. Farmers and potato seed production companies can be faced into great hamper. Although this disease devastating disease can be controlled by using traditional fungicide like carbendazim metalaxyl. In these cases, plant growth and tuber formation are gradually inhibited in this application. As a result, farmers and seed potato production companies cannot get sufficient production or expected yield. The objective of this research is to standardize the protocol by which the lead blight disease can be controlled easily without inhibition of the plant growth and its yield. Here the data to comparative studies, the fungicide treated plant and lead blight affected plot. The production per acre for fungicide treated plots 20 ton. In the other hand, 4 ton yield are in the lead blight affected plot. The production per kg fungicide treated plots 7.5 taka. On the other hand, lead blight affected plots, the production cost per kg 25 taka. So it is clear that lead blight, if affected to the field, farmers and other seed producing company face into a great hamper and lost their cash objective. The main theme of the research is control the devastating lead blight disease without inhibition of plant growth and yield. One of the major objectives of this research is to standardize the dosage and concentration of fungicide we use for controlling the lead blight disease on seed potato production. In scientific basis, in low concentration, pathogens become resistant. It will not be function further. Subsequently, a high concentration from the previous dose will be necessary to control this pathogen. Therefore, it is important to application to standard doses from the beginning for the controlling the epidemic. Method. The field experiment are carried out in different potato project, experimental farm in Rajshahi, Thakurgaon and Dinajpur district in Bangladesh. Advanced varieties diamond, cardinal, asterisk, lady rosetta are planted in an randomized complete block design with 4 applications. For replication consists on acre land and and all treatment are curative and prophylactic spray. 10 selected fungicides are collected from the local market. These are given below. Endrophil, this is one kind of mancozeb. Sonaxilin, this is one kind of mancozeb. Ponta, Autostin, Carbondazim, Redumil Gold, Actifos, Acrobat MZ, Campanion, Blue Green Mancozeb, and Cabriotop. This is the equation. Next, result. The experiment were conducted in investigation investigated the effectiveness of the fungicides against the lead blight disease. 5 fungicides are used against the lead blight disease management in this experiment. The experimental field indicated as a plot number. 4 of the fungicides were used in different concentration. 0.2%, 2.5%, 3%. That means 2 kg, 2 gram of fungicides per 1000 ml of water. 2.5 gram of fungicide per on 1000 ml of water. 3 gram fungicide means per 1000 ml of water respectively. Fungidal solution are prepared by dissolving depaneted amongst the chemical in the different quantity of clean water. This is the method of the application. This is the table. Here, Redumil gold অর্থাৎ metalaxyl with mancozeb or spray in different plot 1, 2, 3, 4, 3 plot and different concentration and in the different doses. আমি মিটিং এ আছি পরে কথা বলবো। So sorry. So this is the lead blight disease control percentage are showing in the table. In this table, the highest percentage of disease control are found in the 97.92 and the yield to 23.667 ton per hectare. On the other hand, when use the carbondazim with Redumil gold, here lead blight disease are controlled smoothly, but its yield comparatively hampered. This was 10.87 ton per hectare. This is the most devastating condition. ভাই মিটিং এ আছি তো আমি। Okay. Next. This is another table. Here, the table after affecting the lead blight disease. The previous table was the before lead blight disease affected lead blight. Sorry, I am on to permission 1 minute.
Hello, Dr. Siddiq.
Yes, yes, I am talking to you. I am talking now.
Okay. Okay.
Okay. This table is after affecting lead blood disease. After affecting the lead blood disease, when we applied for carbondazim and metallic seal, then lead blood is controlled, but its yield effectively hampered. This is yield. This disease control 65.7 60.17%, but its yield is gradually hampered. This was shown as 10.25. On the other hand, when we apply sonaxylin combined with Conta, this is hexaconazole group. Here the lead blight disease is controlled in 99.70%. On the other hand, the yield 24.48 ton per hectare. This is the optimum yield. Conclusion. It was concluded that sonaxylin 72 WP in group of sonaxylin plus 8% plus mancozeb 64% act as a best fungicide when applied in prophylactic measure. This is means before affecting lead blight. Sonaxylin 72 WP was combined with Conta. This is the mancozeb. This is mancozeb with hexaconazole or in the active phos. This is group of phosphorus acid. Show the best result when applied as a curative measure. This is meant after affecting the lead blight disease. Plant growth as well as its gradually decrease due to application of metallic seal and carbondazim. Although metallic seal and carbondazim play on vital role to protect the lead blight after appearance the disease, the plant growth, tuber formation along with the yield were gradually inhibited. Therefore, it is recommended that metallic seal and carbondazim application should be avoided to protect the lead blood disease after or before appearance the disease. Thank you very much. This is the book foot cover of my book. This is the book lead blight disease management of potato. In this book, I describe details in the management of the disease. Hope this protocol will be helpful in the seed potato program in the world along with our Bangladesh. Thank you very much. Have any question?
Thank you, Dr. Siddiq. Is anyone having any questions? I think there are no questions. Let's move to our next presentation by Dr. Mohammed from University of Sfax, Tunisia. Doctor, are you ready with your presentation?
Okay, thank you.
Thank you.
Are
Dr. Mohammed. Dr. Muhammad, can you hear me?
Yeah, I'm hearing you. I just want to share my presentation.
Okay, I made you as a presenter now. Please share your screen. Yes, we can see that.
Can you see my presentation now?
Yes, I can see your presentation. Can you make it as a full screen? Guys,
Yes.
please click on the slideshare button.
Yes.
Okay.
Just one moment.
Okay.
Because no.
In the
Yes, I have
in the bottom of
problem.
your presentation, after the comments, you will be having the slideshow button. Fourth icon you need to click.
Yes.
After the comments.
After the comment. Yeah.
Yes.
I want to
Fourth
close the
icon.
window, but it doesn't want to be closed.
Mm-hmm.
I will click again.
We can see your presentation. Please click on the presentation.
Because I will put in full screen.
Yes, so for the full screen, in PPT below the comments, like in the PPT below of your comments, you'll be having fourth icon slideshow button. Please click on that. In the PowerPoint presentation only. Fourth icon.
Yeah,
Bottom of the
that's
PPT.
now it's okay.
Mm-hmm. Yes.
Can you see it now?
That's perfect. Yes. Please
Perfect. Thank
to
you.
continue with your talk. Thank you.
Thank you for this nice conference. I'm Professor Mohamed Bouaziz from University of Sfax, Tunisia. I will talk to you about the RP-HPLC that cutoff as a powerful tool of phenolic compound characterization in Tunisian olive leaves and the fruit extracts. As an introduction, olive tree is a member of family Oleaceae, is a typical tree in Mediterranean region which is widely cultivated for the production of olive oil. The Mediterranean region has 98% of the number of olive tree in the world. And the stars, when you see the stars in the map, is Sfax, my town. North African olive farming is largely dominated by the Tunisian olive grove with 96% million tree and more than 1.8 million hectare. Shimleri variety is the dominant. It represents 60% of total planting of olive tree in Tunisia, in the south and the center. Olive oil remained stable during the storage period. This due to the presence of phenolic compound with antioxidant activity which increase its lifespan and protect its organoleptic quality. Olive leaf also have a long benefit from medicinal reputation. This due to the potential is considered as a potential source of natural phenolic compound of therapeutic interest, giving the increasing use of the plant extract as a source of antioxidant, nutritional supplement, or even drugs. It is necessary to define their quality by identifying their chemical composition. Let's go for the history of Tunisian olive oil. As you see in the map, the olive tree is rich in its history of the Mediterranean region. The culture of olive oil goes to the ear. It was first brought to Tunisia from Middle East by ancient Phoenician founder of Carthage. This can show you some photo about the monument that we can find it in Tunisia. It tells that olives is very old cultivar, very old culture in our country. And this is, you can see an old manufacturer monument and the container where we storage olives. And on the left, you can see the oldest olive tree, which has about 2,500 years, since 2,500 years. It's very old tree. The olive byproduct, you can see the fruit, table olives, olive leaves, olive wood, olive oil, and also olive meal wastewater, which is obtained after extraction olive oil. Now, olive byproduct, is it waste or a raw material for the future? For that, we are thinking to valorize olive byproduct by separation identification of polyphenol by chromatographic spectroscopic technique such as LCMS, chemical and enzymatic synthesis reaction and stabilization of phenol compound, and by performing biological activity test in vitro and in vivo. Let's go to talk about phenolic compound. Polyphenol constitute a set of molecules widely distributed in the plant kingdom. Structure of polyphenol are one or more aromatic ring contain one or more hydroxyl group. We can find polyphenol in olive byproducts such as succouridoid, simple phenolic with a ring of 6 carbon, phenolic acids, ring of 6 carbon and 2 carbon of acids, flavonoid, and lignin. The field use of polyphenol from olive byproduct is very large. You can see as a medicament, as a cream, as a shampoo, as antifungic, and others. The biological activity of this compound are very interesting, such as cardiovascular protection, neuroprotector effect, anti-cancer effect, anti-inflammatory effect, and also antiviral effect. Phenolic compounds have an high antioxidant activity, such as flavonoid, as you see here, the source, lignin, stilbene, phenolic acid, and alcohol phenol. The problem nowadays is the use of BHT or BHA and other compound for stabilization of food and for medicinal. However, these compounds are now known that these have an allergic effect and carcinogenic effect. For that, European Union has not given a law to use this compound for stabilization. For this, we are thinking about phenolics from olive byproduct, and we are using these compounds such as nutraceutical. As you can see here, all the medicinal is constituted by phenolic compounds such as quercetin, such as hydroxytyrosol, oleuropein, and others. And you can see increasing the use of natural compound from olive oil product and other plants. Also, phenolic compounds are using in cosmetic, such as cream, anti-aging, and anti-stain, product, sunscreen, and solution, clothes washer. We can see from all this, the world market of natural cosmetic is estimated at $9 billion with annual growth of 5%, and 6% of the global cosmetic market. It means that phenolic compound, it is very useful for cosmetic. And from this figure also we can see the increasing of the number of publications on phenolic compound from olive byproduct and other medicinal plants. Now, olive byproduct is a challenge application in agro-food, cosmetic, and pharmaceutical industry. Here I can give you, as we talk about olives, we can see the map of Tunisia, and we can see that this tree is spread in all the country with different cultivar. And the surface in Tunisia is the second country in the world which have a surface is 18.6% after Spain, planted by olive tree. In Tunisia, we have 1.8 million hectare. It is 1/3 of cultivated farmland. It's about 180,000 tons of olive oil. It's about 6% of the world production. In Tunisia, olive production and byproduct, and this represent about 1,750 units of extraction, 10 of pomace extraction factory, 13 edible oil refining, and 24 packing units of olive oil. But the most interesting thing in Tunisia is the number of the person who work totally in olive oil sector is more than 1 million. It's about 10% of the population working in this field. Now we go for the study that is interesting for this conference. Is about the chemical composition and the analytical method used to identify this compound in this byproduct, the chemical composition of olive oil that make its original. Olive oil composition, it contains about 98% of triglyceride and contained another fraction not more than 2%. And this 2% is very interesting. It contains more than 230 identified until now compounds. We can find hydrocarbon, aromatic compound, chlorophyll, phenolic compound, tocopherol, and phytosterol. And we have phenolic compound. As phenolic compounds such as holoropine is very interesting compound, which during the extraction hydrolysate in holoropine glycol, and legistroside, which give also legistroside glycol. These compounds have a taste, such as holoropine glycol is a bitter taste, and legistroside glycol give astringent taste, and oleocontal. This compound is very interesting, especially for Alzheimer's disease. It is containing in the olive oil. It has a taste ardent. And here you can see the hydrolysis of the compound, which compound derivative that can be obtained, such as a hydroxytyrosol. It have a high potent antioxidant activity, and tyrosol a little or not antioxidant. And here you can see the mechanism of phenolic compound to stabilize, for example, oil or cream. Now, production of high added value molecule from olive fruit. 25 phenolic compounds from different families have been identified in the fruit of Shimneli variety, such as hydroxybenzoic acid, hydroxycinnamic acid, phenolic alcohol, iridoid, and flavonoid. The structure of some isolated unidentified compound, hydroxytyrosol, lithiolink 7-O-glucoside, rutin, and tyrosol. And for the first time, using LCMS and NMR, we have identified this compound, which is vicinin 2 in olives. We have identified also other compounds, such as holoropine glycoside. The structure, we have two structures. We have two possibilities, and this using LCMS, and from this table you can see the mass spectra, the retention time, and the fragment of each compound identified. And here an example of nezonide. It's a phenolic compound identified from olive fruit. You can see by LCMS the mass is about 685, and by MS2 it was very easy to identify this compound. And the aglycons was we were giving the fragmentation chain with its confirm this structure, as you see in this slide. Another compound, identification of oleuropein glycoside. You can see here that using LCMS, it was easy to identify this compound. This compound contained two sugar, 162. It was the oleuropein aglycon is about 539, and when he lost the sugar, it gives 377 is the aglycon. And here you can see the fragmentation and the possibility of this compound. It means that LCMS is very useful tool to identify such compound. Now, the production of molecule with high added value from olive leaves. Oleuropein is the main and dominant phenol in olive leaves. We have tried many solvents and we find that methanol water was the best solvent to obtain the high content of this compound. And in order to obtain another compound which is a high added value from hydrolysis of oleuropein, which is named hydroxytyrosol, it is known by high activity, we will see it later. We are trying to hydrolysate oleuropein and to obtain this compound. We have tried two ways. The first way is by enzymatic hydrolysis and the second way by chemical hydrolysis. And we will see what we obtain. By chemical hydrolysis, we obtained only one compound, hydroxytyrosol, and other derivatives. However, by enzymatic hydrolysis, it is two steps. The first step to obtain the oleuropein aglycon, also is interesting compound, and the second step to obtain it hydroxytyrosol, which is very interesting compound, which we can be used in several fields such as pharmaceutical, food, and others. We are trying to quantify this compound using these two ways of hydrolysis. And we have taken 100 grams of leaves and we obtained 6.8 grams of oleuropein. By chemical hydrolysis, we obtained only hydroxytyrosol 2.3. However, by enzymatic hydrolysis, we obtain oleuropein aglycon 3.8 and hydroxytyrosol. It means that the leaf of Chimneri have a high concentration of oleuropein, 35% of the maize extract. Now, another byproduct is olive meal wastewater. Olive meal wastewater is rich in phenolic. It is a liquid that is obtained after extraction of olive oil from the fruit. It contains especially water and phenolic compound. We have tried to analyze this residue, and we find that it is very rich in hydroxytyrosol, which we look for to isolate because it is very good compound. And we have found after quantification that its concentration is 1.43 grams per liter. Every liter have 1.4 grams. And it means this is a huge compound, as we have a huge quantity of wastewater from olive extraction. Now, why we are looking for hydroxytyrosol? Hydroxytyrosol is a major compound in the crude of ethyl acetate extract of wastewater. 100 milligrams is about 800 euro. Due to its interesting biological activity, hydroxytyrosol is considered as a molecule with high added value. It has a lot of activity, such as antiviral activity, and we have tried it for corona, neurodegenerative disease, activity, cardiovascular analysis, and antioxidant activity. In order to stabilize this compound, we have tried to acetylate the hydroxytyrosol, the hydroxyl group, and we try and we are succeeded to stabilize this compound. Can you see in chromatogram the compound was at 10 minutes, and now we obtained a new compound at 41. and we are testing this compound before stabilization and after stabilization, and we find that the activity is still here. And other thing, using LCMS, it was very easy to identify these peaks in the mass spectra, as you see in this figure. Now, I want to show you the Mediterranean diet and why you are using white olive oil and olive byproduct is interesting. You can see here olive oil should be used every day. However, fish and volaille and chicken and eggs could be 1 per week, and red meats and other 1 per month. For that, it is very interesting to consume olive oil like red wine also. At last, should give you some photo of my city town, and I hope you will visit us one day. And thank you for your attention. Thank you. Simon, do you hearing me? Hello? 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 Hello?
శ్రావణి ఒక నిమిషం.
Hello? Yeah.
హలో.
Hello. I'm just finishing. Hello, يا كريم. Hello. Hello.
Can you hear me?
Yes, I'm hearing you.
Hello.
Hello. I'm hearing you.
Okay, thank you, Dr. Mohammed. Hello. Yeah,
Hello.
thank you, Dr. Mohammed, for your presence and presentation. Is anyone having any questions?
I'm ready for any questions.
I think there are no questions. Thank you, Doctor, once again for your presence and presentation. Let's move to our next presentation by Dr. Dr. Sampson, but due to some emergency, he was unable to attend today's conference. And let's move to our next presentation by Dr. S. Motaliva from FHRCBA in Russia. Doctor, are you ready with your presentation?
Yes.
Now I made you as a presenter now. Please share your screen. Hello, doctor. Hello, Dr. Svetlana Motliva. Doctor, can you hear me? We are unable to hear your voice. We can see your presentation. Dr. Svetlana, can you hear me? Hello. Hello, Dr. Svetlana. Can you hear me? We can see your presentation, but we are unable to hear your voice. Can you please check your microphone?
It is on.
Yes, now perfect. Please continue with your talk. Nape.
Hello, doctor.
Dr. Svetlana, we can hear you, we can see your presentation, but we are unable to hear your voice again. Can you please check your microphone again?
Now you hear me?
Yes, now I can hear you now. Please continue.
Water stress, which causes drought, is one of the limiting factors affecting environment in the global climatic change and adversely affect the crop plants growth and development. Stressful impact of arid conditions causes changes in the biochemical process of plants. Gas chromat mass spectrometry based metabolomics were used to investigate metabolic changes in leaves, C4 plants by drought stress. Oxygen active forms speeded accumulation, and it leads to the development of water stress, to change of chlorophyll structure, to decrease of photosynthetic pigments and metabolites, to damage of plant cells. The most important and actual problem of genetic breeding researchers is to determine the crops that are stable to drought. This regard that using a metabolomic approach as a new direction of molecular genetic researchers to identify the changes in plants under the influence of adverse environmental factors remains and poorly studied direction of breeding. Our objective is was a metabolomic profile of leaves amaranth plants after the drought. It was Amaranthus tricolor cultivar Valentina and Amaranthus cruentus cultivar Крепыш. Amaranth species were grown in seed lines and transplanted into plastic pots with one plant per pot. The substrate moisture content was maintained at from 45 till 40% in the pots with the controlled samples. After 2 months of growth, the degree of drought stress was determined according to the soil moisture content. The watering of the experimental plants stopped until the sign of within appeared. The duration of the soil drought period was 5 days. We used the middle lower leaves our methods. The metabolites analysis was fulfilled in chromatograph GMS Q1050GS by the method of gas chromate mass spectrometry. Capillary column was DB5HT. The temperature of gradient during the analysis was from 40 till 280 degrees. We holding temperature at 280 degrees for 40 minutes. The temperature of the ion source was 200 degrees. Helium flow is in column was equal 2.0 milliliters by minute. We use split flow injection mode. Sample injected in volume 2 microliter. Split 20. For ionization mode, we used electronic impact at 70 electron volt. BSTFA was used for 3-methyl silylation for 30 minutes. The temperature was 100 degrees. The identification of substances was done in accordance with holding values and mass spectra of NIST-5, National Institute of Standards and Technology Library, USA. Uh, 43rd secondary metabolites were totally determined in ethanol extracts of amaranth leaves. 42 substances were identified in the leaves of Amaranthus tricolor, cultivar Valentina, and 35 metabolites in the leaves of Amaranthus cruentus, cultivar Kripish. Among 9 compounds that possesses antimicrobial characteristics, 5 ones belong to organic acids: lactic acid, pyruvate acid, glycolic acid, acetamide, malic acid, and tartaric acid. One is sugar alcohol, glycerol, one is amide, acetamide, and one is phenolic compound. It is benzoic acid. The content of lactic acid, benzoic acid, malic acid, and manoic acid is 46, 2 and 1.5 times higher in the leaves of cultivar Valentina than in the leaves of cultivar Kripish. Glycolic acid is found only in the leaves and green colored amaranth. Acetamide is only in the leaves of red amaranth. Other organic acid is represented by the following compounds: butanoic acid, glycolic acid, oxalic acid, and 2 butanidioic acid, monoethyl malonic acid, succinic acid, glyceric acid, 2 oxopentonoic acid, malanoic acid, 2.3.4, 3 hydroxybutanoic, butyric acid, arabinoic acid, ketosuccinic acid, fumaric acid, 2 propanoic acid, and citric acid. The phenolic compounds are presented by caffeic acid, vanillic acid, and cinnamic acid. There are also detected the following compounds: glycoside, apizenic acid, 1.2 glutaric acid, sugar acid, it is myoinositol. For amino acids, it's lauric acid, myristic acid, palmitic acid, and stearic acid were only in the leaves of cultivar Valentina. Under drought conditions, the following compounds were synthesized in a significantly larger amount in the leaves of Amaranth tricolor, cultivar Valentina. It is manoic acid by 70 times, myoinositol by 40 times, caffeic acid by 23 times, tartaric acid by 15 times, glycerol by 7 times, L-propylene and serine by 4 times, and glycolic acid, oxalic acid, and lactic acid by 2-3 times. The difference in the synthesis of these compounds were less obvious in the leaves of Amaranthus cruentus, cultivar creepage. Conclusions. Our results are consistent with earlier findings that the accumulation of proline and other amino acids increases with water potential decrease in the leaves. Myoinositol is necessary for absolutely everyone for the synthetic of the substances involved in the transmission of intracellular signals from receptors. It is a vitamin-like substance that affects metabolism and normalize the leaves of sugar and insulin in the blood. It increases the sensitivity of body cells to hormones, supports hormonal balance, and stimulates the proper functioning form of the hormone insulin and the stabilization of carbohydrate metabolism. The present study showed that the Amaranthus tricolor, cultivar valentina, and Amaranthus cruentus, cultivar creepage, are sources of biologically active compounds and have an enriched accident profile. The reported studies was funded by FBR. And thank you very much. I'm finished. Okay. Any questions?
Hello, Dr. Svetlana. Thank you for your presence and presentation. Is anyone having any questions? I think there are no questions. Let's move to our next presentation by Dr. Barov from Russia. Due to some emergency, he was unable to attend today's conference, but we will present his recorded video presentation on his behalf. Thank you.
That oil and gas will soon run out. So mankind needs to think about looking for new environmentally friendly energy. Such energy is bioenergy, which I will talk about in my speech. To understand bioenergy, we must discuss a new knowledge direction predicted beyond theory. We can see expression for groups which contain cosmological vector potential, a new fundamental vector constant, and the length as its quantum number. Gluons are always in permanent discrete changing state. For describing of these changes, we introduce following definitions of vacuum state: 2 plus, 1 plus, 1 minus, 2 minus. Hello, dear colleagues. We know that oil and gas will soon run out. So mankind needs to think about for new environmentally friendly energy. Such energy is bioenergy, which I will talk about in my speech. To understand bioenergy, we must discuss a new knowledge direction predicted beyond theory. We can see expression for gluons which contain cosmological vector potential, a new fundamental vector constant, and the length as its quantum number. Gluons are always in permanent discrete changing state. For describing of these changes, we introduce following definitions of vacuum state: 2 plus, 1 plus, 1 minus, 2 minus. Please understand, we assume that there are no physical space-time ultimate particles, but we have ions of. You can read the main hypothesis of ion theory. We introduce psi function, which defines a probability of such or another vacuum state. We calculate the basic scale of our world. The existence of vacuum states 1 plus with probability equals 100% provides stability of elementary particles, such as electrons. We see the table of basic results of ion theory. You can read more in my books and articles. New non-gauge interaction push out any matter from the region of summary potential diminution. We use a torsion balance and a load placed in magnet. You see the load from back-13 is attracted inevitably in the different region of magnet. It is the new force action. You can see the expression for new force. You see scheme of sodium gravimeter. We use the vector potential of magnet for increasing the new force action. This is the result of these experiments. X presents action of new force. The results of the experiments with two gravimeters. One control gravimeter has not matched. The position 2 is the action of new force. The position 1, 3, 4 are the usual earthquakes. In this experiment, we use the current vector potential of pulsed plasma generator for definition of the cosmological vector potential direction, rotating the plasma generator. You see the result of two experiments with rotation around the vertical axis. It is a final result of this experiment in 6 months. This experiment shown the new force reject substance out of weakened summary potential along the generatrix of coal with an opening of 100 degrees around the cosmological vector potential, having the coordinates right section 293 degrees and declination 36 degrees. New force can influence on beta decay rate. In this investigation, we use the Kolmogorov-Smirnov tests for data analysis. You see, temperature is constant, but beta decay rate has a big deviation near 1 hour PM. It is 13-hour Moscow time. You see the temperature variation, but deviation of decay is very small. This investigation shows that the directions of beta decay rate deviation correspond to the generatrix of new force action called and vector Ig. We use the germanium lithium detectors in this experiment. We get the new force action directions corresponds whole of the new force directions. All astrophysicists know the distribution of the cosmological energy density. Theory of ions show the nature of cold and warm dark matter. The dark matter is a physical space, spatial quantum medium formed during for contact ion-ion interaction. Own energy of this object is equal to 33 electron volt. Theory of ions shows the nature of dark energy because gravitation potential has a negative value. And decreases the summary potential, pushing out galaxies using the new force. The investigation of the anisotropy of theory of ion shows the nature of gamma ray bursts. This process corresponds for short bursts as the birth of universe, but with known interactions. We show those conditions of gamma ray bursts connected with supernova. It is shown the connection of the new force direction vector Ag and the anisotropy of alpha decay in experiment with radium decay in Germany. You see a scheme of heat installation using a new force for getting hot water. This installation uses gravitation potential for realization the new force action. You see the experiment's results with his installation in Italy. We see a fantastic phenomenon in our experiment. The jumps of output-input coefficient is equal to and corresponds the variation of magnetic field in solar wind. The European can explain this phenomenon using new force. You see a first industrial heat installation located near Moscow. Output-input coefficient is equal 1.25. The height of this installation is equal 12 meters. Now, you will see the movie about using of new force as directive force for spacecraft in the terrestrial experiment. The model uses a new principle for power. It uses the physical space as a support medium. The rule shows that any object reduces the magnitude of summary potential where it is located in physical space due to interaction between the potential of physical field of elementary particles. Therefore, if the object returns to its previous position, its place will repel it due to the action of new force. It is not an inequality because we use the ideal sphere for spacecraft model. We cannot change the location of mass center using inner force. Therefore, you see the new force action. You can see the parameters of our heat installation in Novorossiysk town. This is the first heat installation using their own energy. So, you see using our own energy for heat installation and spacecraft model. Thank you very much.
Thank you, Doctor, for your presence and presentation. If you're having any questions related to the recorded video presentation, you can send your query to the respective program manager, and they'll reply you back. Thank you. By this, we came to our day 2 conference end. I would like to thank all the attendees and participants of today's conference. Hope you enjoyed the conference and gained knowledge from the sessions today. And I request you all to attend our physical conference too, in-person conference. If you're having any questions, you can mail to the respective program manager, and we'll be glad if you could join in our next conference, which is scheduled, and details will be informed to you by email. We'll be very happy if you could share your opinion and feedback with us. Thank you once again for everyone for your presence and presentation. Thank you.